In the last video, I did a brief introduction to adding and subtracting vectors. In this video, we're going to concentrate on how to solve vector addition and subtraction graphically using the tip-to-tail method. To solve graphically, it's very useful to have things like a ruler, a protractor, and graph paper, because solving it graphically does involve drawing everything to scale. Now, sometimes you can do it by sketching, but if you want exact answers, you're going to have to do it to scale. And one of the ways that you can add lots of vectors is the tip-to-tail method. To demonstrate the tip-to-tail method, I'll take the two vectors we were using before, 5 meters per second to the right, 7 meters per second down. And our goal will be to add these together to get c equals a plus b. Now I'm just going to draw it, and I'm going to section off a side here so that we can do more work to the right of the screen. The first step is to define a starting point. The second step is to draw vector A, the first vector, starting at the start point. And I can now define the tip of vector A. The next step is to draw vector B, the next vector we're adding to the first one. And we do that by putting the tail of B on the tip of A. So basically you draw B, but starting from the tip of A, hence the idea of tip to tail. Now, if you were adding multiple vectors together, in other words, more than two vectors, you just keep doing this process, putting the next vector starting from the tip of the previous vector. And you would continue doing that until you basically finished adding all the vectors onto it. When you finished adding all your vectors tip to tail, the tip of the last vector added, in this case B, will become our endpoint. We know that the sum of vectors is also a vector, in this case it'll be c. We sometimes call that the resultant vector, or the vector sum. To get this, what you need to do is draw an arrow from your start point to your end point. This will be your resultant vector. I'll draw it here in blue so you can see it. Now, if you've drawn everything to scale and done it correctly, you should be able to just take a ruler, measure the length of that resulting arrow, and using your drawing scale, you should be able to find the magnitude of that vector. As well, you could take a protractor and measure the angle that vector makes with some arbitrary axis, usually a horizontal axis. That way you can define both the magnitude and direction without doing any mathematics. Now I'm just going to cut and paste that arrow and put it over to the left side of the screen because I want to show you another interesting property. What would happen if I were to try and add them together in a different order? And in this case, I would add B plus A. I'll quickly draw out the tip-to-tail addition of B plus A. And then I'll also draw the resultant vector, the sum of B plus A, in blue. And you should be able to see it's the same result as we got when we did A plus B. The fact that doing it as A plus B or B plus A gives you the same result is an example of the commutative property of addition. So you can add vectors in any order. Let's try another example. This time it'll involve 4 vectors, A, B, C, and D, as I've drawn here, and we're going to add these together. So to begin, we'll pick our starting point and we'll draw the vector A. And on the tip of A, we will draw the vector B. Okay, this next part is a little hard to show on this screen, but adding vector C, it's going to go right on top of the line that's part of vector B. It's going to be 4 squares, 4 meters per second, pointing upwards. So we have to draw it right on top, and I'll try to indicate that as best I can with the arrow here. And finally, we can add vector D to the tip of C. So we've added all these vectors together by using tip to tail, and now we've ended up with our endpoint. And just like before, to find the vector sum, we just draw an arrow from our starting point to our ending point, and this is the resultant vector. This is the sum A plus B plus C plus D. The nice part is you can see you could do this for any number of vectors. You could add 100 vectors this way. You wouldn't want to, but you could. Now, I just wanted to quickly show you too that the commutative property works here, and it's sometimes easier to draw. In this case, I'll add A plus B plus D plus C. So I'll reverse the order of C and D, and you'll notice we'll get the same answer. It's just a little easier to draw since you don't have to draw overlapping lines. So I just thought I'd show you that. So that's how you can add any number of vectors together. But how does one subtract vectors? That's what we'll take a look at right now. All right, let's take the two vectors we've been using as examples here, vector A, vector B. And now let's find vector D, which we'll define as A minus B. And we'll figure out how we actually do that. The key to vector subtraction is remembering from an earlier video when we did multiplication of a scalar times a vector. And we saw that when you multiplied a vector by a negative number, you got a vector that was in the opposite direction. So in other words, if I took vector b and multiplied it by a scalar -1, I would get a vector that had the same magnitude as b, but would be pointing in the opposite direction. Now this is helpful because I could rewrite d equals a minus b instead as d equals a plus -b. So now I can do vector addition with a and -b. So I'm just going to take my b vector here and convert it to -b just by reversing the direction of it. And now I can just do tip to tail a vector addition with a and -b. So we'll just do what we did before. And now we have our resultant vector just like we did before. Let's try a 4-vector example. This time what we'll try and find is a plus b minus c minus d using the tip-to-tail method. So I'll just draw it here tip-to-tail, noticing that I reversed the directions of c and d, so I added -c and -d. And there's my resulting vector drawn in blue. This brings us to the end of this video on adding vectors and subtracting vectors graphically. In the next video, we will start to look at how do you add and subtract vectors mathematically using the idea of components. There's a link to that next video on the screen, as well as a subscribe button if you wish to subscribe to my channel. Thank you for watching, and have a great day.